One of the most important properties of Bitcoin is the ability to create private transactions. So as we know from the original Bitcoin white paper, Bitcoin was designed in such a way as to be pseudonymous. That is to say, basically the addresses do not map knowingly to individuals that are like real-world identities. But it's very easy to leak this information somehow. So if we reveal to someone that you have a particular Bitcoin address, anyone can now track your transactions using that Bitcoin address because the blockchain itself is completely public. So for instance, if you were to use the same address for every single transaction forever, it's very easy for someone to track that entire transaction history by querying the blockchain. So you shouldn't reuse addresses really ever, unless you're doing this in a very conscious way for some particular reason where you know that you're basically giving up your privacy. Now in theory, if you never reveal your address, you could have the same, use the same one without violating your own privacy, but that's very unrealistic because other people might leak it for you. You could say send a transaction to someone and they have a record that they receive money from you and that's your particular address, and then they leak it. So if you have poor privacy using Bitcoin, it actually decreases the privacy of everybody else that you interact with. Okay, so it's you need to be sort of well, ideally the end user doesn't need to be aware of this whatsoever, but people that are building on this need to be aware of this, that we do need to manage and take care of the privacy situation and really improve privacy. So this is something we did with MoneyButton early on. Part of the reason why we rewrote the wallet infrastructure from yours when we created MoneyButton was to make sure that we had multiple addresses. So MoneyButton has had multiple addresses since day one. That is to say, when you receive a new Bitcoin transaction at MoneyButton, it always uses a new address, so they're not necessarily connected to each other. So we increase the amount of privacy that you have. If somebody figures out one of your addresses, they don't necessarily know any of the other addresses. Now, I want to say there's a way that you can figure out that somebody has sort of multiple different addresses, which is anytime you have multiple UTXOs, which is basically payments to an address. You have more than one of these, so you might have, say, 10 addresses, and you've received a payment in each one of them, and now you have 10 UTXOs, and you need to make a payment that's big enough that you need to spend all of them. The usual way you do this is to actually create one transaction that merges every single one of those transactions together. So you, say, have one BSV and 10 different UTXOs, and you need to send 10 BSV to someone. You merge them. Now anyone can see on the blockchain, well, gosh, if all 10 of those UTXOs were spent in the same transaction, probably one person owned all 10 of them. It's not a guarantee, but it really narrows it in on the fact that one person probably owned them. So if you have previously leaked one of your addresses, that person who sees that address, such as someone who sent you a payment, can now actually link the rest of your addresses together. So it leaks privacy. So there's an idea created by Mike Hearn a number of years ago. I believe he was the first one to originate this idea. It goes back to something like probably like 2011 or something like that, called merge avoidance. So there's something we can do to actually basically maintain a very high level of privacy, even though all the transactions on the blockchain are public. If you never merge your UTXOs together, no one can just link them together by looking at the blockchain. So we can really increase privacy doing it this way. Now, here's the catch. Every wallet right now, basically every single wallet, relies on the idea of sending to an address. There are tons of issues with this, which I've covered in other issues. I'm going to talk about the privacy issue right now. If every single wallet relies on sending to an address, then what you do is, in order to send a transaction to that address, you have to create a transaction that sends the entire amount to that address. This is a problem because basically you have to merge UTXOs to send to an address. We should move to a model where instead of sending to an address, the user, first of all, shouldn't see the address whatsoever. What you should see instead is, you should see who you're sending money to, and underneath we have a protocol to allow sending multiple different transactions simultaneously. This will allow you to do merge avoidance in practice. So we can do this with Paymail and BIP270. So actually built into the original BIP70 was the ability to send multiple transactions. There are different ways we can talk about this, but let me just explain it in a high level way why it's important to use these technologies to do something like this. So first of all, in order to send a payment to someone else, you should never have to copy and paste an address. I mean, this is just this is a user experience nightmare to ever see something like this. But we're going to need something where, like, in order to send a multiple list of addresses back, because under the hood there's still going to be addresses. You're still going to send to a normal pub key hash output, but you're going to send to many of them, and you're going to send from different transactions. So what you need to do is you need to have the ability to send to someone. So we need a naming system. We need a naming system that we can query. We've solved this problem with Paymail. Paymail is just the same thing as an email address. We use DNS as the underlying naming system with a sort of sub-naming system on top of it, which is equivalent with email. We did this for lots of reasons. Most importantly, it's something that's consistent with existing businesses, so companies like Google and Microsoft will be able to simply add support for this without having everyone change their name. But what we do is we have the ability to query a Paymail, because you can go to that DNS record for the domain name, find a host that actually has an endpoint that you can then query. You send it the email addresses, that is to say the Paymail address, and find the services that they support. And you can do things like get an invoice that you can then pay. So you can type in someone's name and just pay them money. So under the hood, what's going on is the Paymail gives you back a list of addresses that you can send to. The user doesn't see the actual addresses. All they know is they're paying the correct amount of money to the correct person. But under the hood, what's going on is, by getting a long list of addresses, you can then use merge avoidance. So you can say, okay, I've got 10 UTXOs, and I got 10 addresses from this person. I'm going to create 10 different transactions and give them all 10 of them. That way you don't link your UTXOs together. Okay, this is merge avoidance. You do not merge your UTXOs into a single transaction. This has extremely good privacy properties. And you basically need something like Paymail. You need a naming system, and you need a query system, which are both provided by Paymail. So this is just an example of something we can do with Paymail. Of course, there are lots of other things we can do. Using the same technologies with Paymail and BIP270, we can do all sorts of advanced transaction negotiation features. So we can do things like coin join in a protocol doing this. So coin join is a completely different privacy technique. I won't try to explain coin join right now, but I want to explain another one that Craig has talked about before. We can do things like private Bitcoin addresses where no one else knows what address except the sender and the recipient. So the way to do this is the idea of using Diffie-Hellman to arrive at a shared secret for an address. Again, we thought about this very smartly in the original design of Paymail. So we have something called the identity key. The identity key is a public key. The sender can actually do Diffie-Hellman, which is to say use one of their keys, find a shared secret with the recipient. What they can then do is generate a new address that actually looks random and is not deterministically generated by anything other than the sender and the recipient. Because you would have to have one of the private keys to be able to do that. So long as you never leak your private keys, no one else can ever know what that address is that you share. Or you could leak it, but don't leak it. So keep these things private. No one else can generate this automatically. So you can have as compared to say a BIP32 key where you can derive a bunch of new addresses. The thing is, if you ever leak that BIP32 key, everyone can derive every single other address and link everything together. So you want to have things that are effectively random that other people can't deterministically generate. So BIP32 has wonderful properties, but we can go slightly better than that and use Diffie-Hellman for this. So this is something Craig has talked about extensively going back at least a couple years or so, this idea of using Diffie-Hellman. We can do that with Paymail. We're going to use the identity key. You generate new addresses with Diffie-Hellman, so you can send to someone as many different addresses as you want to, and then with the transaction, using the BIP270 payment transaction broadcast endpoint, you can send metadata to let them know, metadata off-chain, what addresses you generated. So using these techniques together, we can use Diffie-Hellman and we can use merge avoidance. You send them a list of transactions to new addresses to which no one knows, not even the recipient knows what they are until you give it to them. Now, no one can link these together. I mean, no one has the knowledge that these all belong to the same person. Okay, so these are the types of protocols we can build into Paymail. Again, I'm only scratching the surface here. These are things that we can do reasonably near term with Paymail to maximize the privacy of Bitcoin. So in order to have maximum privacy, we need technologies like this. Now, are there better ways to do this? There might be. I have yet to see a better way to do this. So we're moving forward with Paymail so long as basically we can solve every single one of these problems. We're going to maximize privacy. We're going to maximize scalability. This is how we have a maximally private and maximally scalable global public blockchain infrastructure for the entire world that underpins the information architecture of things like the internet and the economy, as well as the money and contracts and financial instruments of everything. We can and will solve every single problem. And long term, what we'll probably do is basically once we get more real businesses on board with this type of thing, DNS itself can end up on-chain, as I've described in a previous video. So basically you want to do things like, again, take a bunch of ideas from nChain because they've talked about things similar to this, but you can do things like put PKI on the blockchain, which is basically what you need inside DNS to do things like DNSSEC and stuff like this. We put the naming system, all this stuff. So as the blockchain grows and we get all these people using it for stuff, it'll simply become in their interest. They'll end up into a situation where like DNS will just like, it'll be easier for it to be on chain. Someone will replicate it there first and so on, so that you can use it for whatever. And then eventually we just start using Bitcoin directly instead of using these internet things. So this is how we get a naming system on chain. And it's a naming system that's completely compatible with everything that we're doing right now. So anyway, that's it in a nutshell. We should and we can and we will maximize privacy on Bitcoin using Paymail, and as well as scalability and stuff like that. So anyway, thank you for listening to this video.